Greeting of the day, dear students. Today, this is the part 2 of the chapter Polynomial of class 10th. Today, we will be discussing about the zeros of the polynomial, how differ is the zeros, roots and the solution of any polynomial. Today, we will also try to build up the relationship between the coefficient and the zeros of the polynomial. At the end of the video, we will also learn how to check whether the zeros of any polynomial is correct or not. Okay, so generally 3 topics we will deal today. So let's get started with the zeros of the polynomial. Dear students, zeros of the polynomial. The zeros of the polynomial are the value of variable of any polynomial for which the polynomial is 0 is known as the zeros of the polynomial. Suppose, dear students, I have written p of y 2y plus 3. Here this is an algebraic expression. Okay, so here the variable is y, so p of y is an polynomial for this algebraic expression. Suppose the statement says that the zeros of the polynomial is the value of the variable for which the given polynomial is 0. So this third line, the given polynomial is 0. So let's consider that p of y is 0. This implies that p of y will be 2y plus 3, which is equals to 0. This implies that when we transpose this 3 to there, we get 2y is equals to minus 3. Here the value of y will be minus 3 by 2. Noteworthy point is that, dear students, that for the value of y, which is minus 3 by 2, this polynomial p of y 2y plus 3 is fully satisfied. That means if I put the value of y as equals to minus 3 by 2 for this polynomial, I will get p of y is equals to 0. Let's double cross check it. So for to check, put y is equals to minus 3 by 2 in p of y 2y plus 3. Here when you put the value of y here in this algebraic expression, we get y is what? 3 by 2 plus 3, 2 will get cancelled, that will be minus 3 plus 3, that is p of y minus 3 plus 3 is 0, so p of y is 0. Okay, in this way, suppose let us take another example. This is example number 1. I have now the geometrical meaning of the zeros of the polynomial. Dear students, the number of times the curve of any polynomial is touching the x-axis is the number of zeros possible for that. Let me write it for the better impact. Number of times the curve of polynomial touching or cutting the x-axis. The x-axis is the number of zeros possible for it. Suppose, as I have taught you in an earlier video lecture, that for a linear polynomial the curve is always straight, isn't it? Yes. Let us take one example. P of x is, I am writing, is a 2x plus 3 is a one polynomial. Okay, I just want to plot the graph for this. So what I will do, I will take the value of, I will make a one table. What that will be table? Suppose x, I will keep the value of x something and I will get the value of p of x. Suppose I put the value of x over here as equals to 0. Then what will be the value of p of x? It will be, if let x is equals to 0, then p of x will be 2 into 0 plus 3, that is p of x will be 3. So p of x will be 3. Suppose I put let p of x be 0. Then this 0 will be equals to 2x plus 3. Transposing this to here, we will get minus 3 is equals to 2x. Again transposing 2 from here to here, we will get minus 3 divided by 2 is equals to x. So when we put the p of x is equals to 0, we get the value of x is equals to minus 3 by 2. Let us just try to plot this 2 coordinate on the graph. So this is our x-axis, this is our x dash, this is our y-axis, this is our y dash. Suppose this is 1, this is 0, this is 2, this is 3. 1, 2, 3. Minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. What do you think? Where will this 0, 3 coordinate will fall? 0, 3 coordinate will fall here. This will be 0, 3. What is the plotation for minus 3, 0? That will minus 3 by 2 is 1.5. So 1.5 will something lies here. So this is minus 1.5. So minus 3 by 2 will be here only. So this is minus 3 by 2, 0. Just join this 2 coordinate using scale. You will get that, you will get a straight line representing 2x plus 1 polynomial. Here you can observe that this straight line is touching the x-axis only one time. Just see the definition. Number of times the curve of polynomial touching or cutting the x-axis is the number of 0 possible for it. So here the graphical representation of p of x 2x plus 3 polynomial is a straight line which is touching the x-axis only once. Okay, so here it proves that the number of times the curve of polynomial touching the x-axis, the number of zeros it has possibility. Okay, now let us take another example. Now dear students, I am taking one quadratic equation and we will learn how to plot the graph for that quadratic polynomial. Suppose p of x is x square minus 3x minus 4 is a quadratic polynomial. Obviously it has a degree 2, so it is a quadratic polynomial. Here we wish to find we wish to represent this quadratic polynomial into graph. So by hit and trial method we will put the value of x different and we will get the value of p of x different. So I am just making one table. Upper side is x, so downside will be p of x. Suppose the value of x is 0 here. If x is 0, then we will get p of 0 is equals to 0 square 3 into 0 minus 4, that is just minus 4. Okay, so p of x will be just minus 4. Put x is equals to 1. If you put x is equals to 1, we get 1 square 3 into 1 minus 4, that is 1 minus 3 minus 4, which is plus ka 1 minus 7, which is minus 6. So p of 1 is minus 6. Okay, now put the value of x is equals to 2 here. You will get p of 2 will be equals to 2 square 3 into 2 minus 4, which is 2 square is 4, 3 into 2 is minus 6 minus 4. Here 4 will get cancelled out, only minus 6 will remain. Okay, what is value of p of 3? P of 3 will be, so when x was 2, the value of p of x was minus 6. Okay. What is the value of p of 3? When we put the value of x is equals to 3, we get p of x is equals to 3 square 3 into 3 minus 4, that is 3 square is 9, 3 into 3 is again 9, that is minus 4. So 9 will get cancelled, only minus 4 will remain. Okay. So for the value of x is equals to 3, we are getting p of x is equals to minus 4. Let us take x is equals to 4. Suppose x is equals to 4, then this will be 4 square, 3 into 4 minus 4. 4 square is 16, 3 into 4 is 12 minus 4. 16 minus 16 is 0. So for the value, when we put the value of x is equals to 4, p of x is 0. Okay. Now let us see for the next natural number, that is 5. So p of 5 will be what? That will be 5 square minus 3 into 5 minus 4. 5 square is 25, 3 into 5 is 15 and minus 4, that is 25 minus 19, that is just 6. So for the value of x is equals to 5, we are getting p of x is equals to 6. Okay. Now putting the value of p of 6 is equals, putting the value of x is equals to 6. So when we put p of x is equals to 6, we get p of 6 will be equals to 6 square, 3 into 6 minus 4, 36, 18 minus 4, 36 minus this is what? 22, which is equals to 14. Okay, this is what? 14. For the value of 6 is 14. Okay. Let's try to put the negative numbers for the value of x. So when you put the negative numbers, that is, let's say minus 1. For the minus 1, for the value of x is equals to minus 1, we have p of x is equals to, just check, p of minus 1, it will be minus 1 square, 3 into minus 1 minus 4, that is, now this will be, when you put the x is equals to minus 1, p of minus 1 will be minus 1 square minus 3 into minus 1 minus 4. This will be minus 1 square is just 1, 3 into, here negative of 3 multiply with negative of 1, so that will be just 3, that is minus 4 is minus 4. 1 plus 3 is 4 minus 4, which is equals to 0. That is, for the value of x is equals to minus 1, we are getting p of x is equals to 0 only. So minus 1 is equals to 0. Now take another number. Suppose x is equals to minus 2. We get, putting the value of x is equals to minus 2, we get p of minus 2 is equals to minus 2 square, 3 into minus 2 minus 4. Minus 2 square is 4. Minus 3 into minus 1 is just positive ka 6, and that is minus 4. So minus 4 will get cancelled, only 6 will remain. So for the value of x is equals to minus 2, we are getting the p of x is equals to 6. Here, dear students, try to understand. Here the range for p of x is varying from minus 6 to plus 6. Okay, so we will neglect this term 6, we will neglect this coordinate 6 comma 14, because generally this value of p of x are periodic, they repeat their value after some time. So it is, since it is ranging from minus 6 to positive 6, so we will neglect this coordinate which we have put x is x comma minus 14 for the plotation. Okay, so let's just try to plot the things. Okay, so I have drawn the graph, that is, this is our x-axis, this is our origin, this is our x dash, this is our y-axis, this is our origin, this is our y dash. From 0 to there, all number will be positive from 0 to here, all the number line will be negative. From 0 to upside that will be positive, and 0 to downside that will be negative. Let's try to plot this coordinate one by one. Here p of x we will represent as a value of small y. Okay, so here x is equal to 0, y is equal to -4. So when we plot, the coordinate will be x comma y, that is 0 minus 4. Similarly 1 minus 6, coordinate will be 2 minus 6. For this minus 3 minus 4, and for this it is 4 comma 0, and for this it's a 5 comma 6, and we have 6 comma no 6 we are neglecting, because here the value of p of x is ranging from -6 to plus 6, so this will neglect. So next term is -1 0, -1 0, and the third one is -2 6. So we will try to plot this coordinate on this graph. So one by one, 0 minus 4 will be 0 here, -4 is where here. Okay, so this is 0 minus 4. 1 minus 6, 1 is here, 6 is -6 is somewhere here. Okay, so 1 minus 6. 2 minus 6, 2 is here, -6 is again here. Okay, 3 minus 4, 3 is here, -4 is somewhere here. Okay, parallel to this here. Next term is 4 comma 0, 4 is here, 0 is here. Okay, 4 0 will lies here. 5 6, 5 and 6 somewhere here. This is 5, this is 6, so 5 6 will come here. Next is -1 0, -1 is here and 0 is just here only. -2 6, -2 is here and positive 6 means that will lie somewhere here. So here, dear students, when we compare this with our standard formula, that is ax square bx plus c, one thing is clear, that the value of a is 1, okay, which is greater than 0. And in our last lecture video I have taught you that when the value of a is positive, that is greater than 0, then the horseshoe, that parabola will be open towards the upside. Okay, when a is greater than 0, the parabola for this quadratic polynomial are generally open upside. So when let us try to draw the curve line for this equation. So starting from here we will come to here, then it will, okay, that will come to -6 plus 6 touching to the 4 0, and that will go like this. So the final curve will be like this only. Okay, this is nothing but the parabola open towards the upside. So this is the curve for this equation x square minus 3x minus 4. Here as you can see that geometrical representation for this quadratic polynomial, here the curve for this polynomial is touching the x-axis 2 times. Okay, so number of times the curve touch of the polynomial touching the x-axis is the number of zeros possible for it. Here number of zeros is possible only where that will not -2. -2 is there? No. -1, -2, -6. So let's just try to find, like it will touch here only, no? -1 and 0. Okay, let me rectify it. So basically I just wanted to say that since the value of p of x is coming 0 to 4 for the 4 and 0 and -1 and 0, so this from here this will touch to -1 and 0 and it will go down to here. So from here it will go like this. Okay, now it is correct. Okay, previously I have considered this -2 and 6 which was wrong. So that is minus, it will touch the curve line -1 and 0, and here it will be 4 and 0. Here -1 and 0, because for the value of x, that is 4, we are getting 0, and the for value of x, that is minus 1, we are getting 0. So anyhow this curve will touch minus 1 0 and 4 0. So this is the curve line for this polynomial. So I hope you have understood the things. So now let us do one exercise from the NCERT. Now dear students, I have one task for all of you. Can you predict the number of zeros possible for the given polynomial by just looking into the graph? The first graph is this. Just pause your video and try to predict the things for 1, 2, 3, 4 questions. Obviously, here since this curve is touching the x-axis only once, so only 1 0 is possible. 1 0 possible. Okay. For the second graph, it is touching the x-axis 1, 2, 3, 4 times. So obviously it is biquadratic, that is it will have 4 zeros. Here this is the equation of linear polynomial. So obviously this will be, here the curve is touching the x-axis only one, so it will have 1 zeros. Okay. Here it is the condition of parabola towards the downside. So and the curve is touching the axis only 2 times, so it will have 2 zeros. So small questions come in your NCERT book. So I hope you have understood the geometrical meaning of the zeros of the polynomial. Now we will learn about how to find the zeros of the quadratic polynomial using splitting the midterm method. Okay. Dear students, now we will learn how to find the zeros of the quadratic polynomial by using splitting the midterm method. Here in this splitting the midterm method, we generally try to divide the midterm in order to take the common and to get the further factor. So let us see the splitting the midterm method, okay, to find the zeros of the polynomial. Suppose we have polynomial p of x 2x square minus 8x plus 6. Here just take the solution. We know that general formula for the quadratic equation is ax square plus bx plus c, where a is not equals to 0. This is the general formula for the quadratic equation. Okay. So on comparing these two standard formula, we get the value of a is equals to 2, value of b is equals to minus 8, and value of c is equals to 6. Isn't it? Yes. So in order to split up this 2x square 8x plus 6 under the splitting the midterm method, we generally think about two number. Think about two number, say p and q, such that their sum, that is p plus q, that should be equals to b. We think about two number p and q such that their sum is equals to b as per the standard formula, and their product should be equals to c into a, that is the constant, and multiply with the coefficient of x square. Okay, so basically we have to think about two number p and q such that their sum should be equals to the b, that is midterm of this standard formula, and their product should be equals to constant multiply with the coefficient of x square, that is c dot a. So here value of b is, bacho, we have taken value of b is equals to minus 8, and value of c is just 6, and value of a is 2. So that is 6 into 2 is 12. So basically we need to think about two number p and q, the value of p and q, such that their sum is minus 8 and their product is 12. Okay. So think about two number whose sum is minus 8 and product is 12. So here by using hit and trial method you can try, like suppose if I take the value of p is equals to, say p is equals to minus 6 and q is equals to minus 2. Here just try to check whether it is satisfied or not. So when we take value of p is equals to minus 6, it will be minus 6 plus minus 2, that should be equals to minus 8. Okay, so minus 6 minus 2 is minus 8, which is equals to minus 8. So it is satisfied for this condition. P is equals to minus 6, q is equals to minus 2. So multiply minus 6 into minus 2, that should be 12. 12, yes. When you multiply minus 6 into minus 2, we get 12 only. So it is satisfied for this condition also. So we have got the value of p is equals to minus 6 and q is equals to minus 2. Let us just try to split the midterm of this 2x square minus 8x plus 6. Minus 8x will be splitted up as minus 6 and minus 2x. Okay, so just see, this implies that p of x can be written as 2x square minus 8x, we are writing as a minus 6x and minus 2x. So this will be written as minus 6x minus 2x and plus 6. Now try to take the common from this first two term, that is we can take common, that is 2x we can take common, remaining will be x and here the remaining will be 3. From 2x square minus 6x we have taken out 2x as a common, x minus 3 will remain. Here also x minus 3 will remain and minus 2 will be common here. So basically this is 2x minus 2 again taking common, and this will be x minus 3. Which of p of x, this is called the factor of the polynomial. By putting the factor of the polynomial is equals to 0, we get the zeros of the polynomial. So just put the factor of this polynomial is equals to 0, so we get 2x minus 2 is equals to 0, and on the other hand x minus 3 will be equals to 0. Here the value of 2x will be equals to just positive 2, and the value of x will be equals to 2 divided by 2, that is 1, that is value of x is equals to 1, and here transpose the things, you will get value of x is equals to 3. So x is equals to 1 and x is equals to 3 are the two zeros of 2x square minus 8x plus 6. Okay, so this is called the method of splitting the midterm. Let us take another example. Okay, now dear students, I have taken another example, that is p of x is equals to root 3 x square minus 8x plus 4 root 3. Here, like similar to what we did in our previous question, you have to solve this quadratic polynomial by using splitting the midterm method. So let us solve this question one by one. So basically we will do the same steps like when we comparing this polynomial to x square plus bx plus c, where a is not equals to 0. Here value of a is root 3, value of b is minus 8, and value of c is 4 root 3. Okay, so again think of two number p and q such that their sum is equals to the midterm, that is b, the mid coefficient, that is b, and their product should be equals to product of constant into the coefficient of x square, that is a. Okay, what is value of b here? Value of b is minus 8, and what is the value of c here? Value of c is 4 root 3 into what is the value of a here? Value of a is root 3. So we know that root m into root m is just m. So root 3 into root 3 is just 3. So that is 4 into 3, that is 12. Okay. So now we have to think about two number p and q such that their sum is -8 and their product is 12. Dear students, you can easily crack this value of p and q, that obviously when we put p is equals to -6 and q is equals to -2. So just check, p plus q, -6 minus 2 is -8, that is satisfied. When we multiply -6 into -2, we get 12. So this is also satisfied for this equation. So now we will split up -8x is equals to -6x minus 2x. So this can be written as p of x root 3x square minus 8x plus 4 root 3. This can be written as बच्चों root 3x square minus 6x minus 2x plus 4 root 3, isn't it? Here try to take the common from here. So from this first two term, if we take root 3 as a common, root 3x as a common, we get x will remain here, and here we will get minus 2 root 3. Okay, so root 3x square minus 6x will give us root 3x as a common, and the remaining term will lies inside the open bracket x minus 2 root 3. Similarly here, taking minus 1 as a common, we will get not minus 1, taking minus 2 as a common, we will get x minus 2 root 3. So from here minus 2 will be we will take as a common, and the remaining things will be x minus 2 root 3. Here p of x will be equals to root 3x minus 2 open bracket again x minus 2 root 3. This is known as factor. As we did in our last question, again we will put the factor to 0. So putting the factor of this polynomial to 0, we get root 3 x minus 2 is equals to 0, which give us, and also this x minus 2 root 3 will be equals to 0. Here this will give us root 3 x is equals to 2, x will be equals to 2 by root 3, and on the other hand the other factor, that is x minus 2 root 3, will give us x is equals to 2 root 3. Okay, so x is equals to 2 by root 3 and x is equals to 2 root 3 are the two zeros of this quadratic equation. Okay, so since it has degree 2, so we are having two zeros, that is x is equals to 2 by root 3 and x is equals to 2 root 3. Dear students, now we will learn how to verify whether the zeros that we have obtained is true or not. To verify the zeros of any polynomial, we have the relationship between the coefficient and the zeros of the polynomial. Suppose x is equals to 2 by root 3 is a 1 0 which we have considered as alpha, and x is equals to 2 root 3 is another 0 which we have considered as a beta. So we have one topic which says that the coefficient of relationship between coefficient of quadratic polynomial and their zeros. Okay, what it says that let alpha and beta be two zeros of quadratic polynomial, then their sum, then alpha plus beta, that should be equals to minus b by a, and alpha dot beta, that should be is equals to c by a, where this is the coefficient of what? X, negative of the coefficient of x, and this is the coefficient of x square. This is the c is the constant here, and a is the coefficient of x square. So coefficient of quadratic, this is the relationship between the coefficient of quadratic polynomial and their zeros. Suppose we want to verify that this polynomial, the zeros of this quadratic equation is true or not. So what we will do, we will just compare the things. Let me write the things. Like we have given value of p of x is this. So here obviously alpha plus beta, what is the value of alpha here? 2 root 3 plus beta is 2 root 3. That should be equals to minus b by a. Minus b by a means what? Minus 8 upon value of a is root 3. Okay, so let's just check whether it is satisfied or not. So here this, by taking LCM, we can write this here 2 as a 2 root 3 into root 3 divided by root 3, and this will be minus 8, so that is positive 8 upon root 3. 2 plus 2 root 3, here is just 3, so 2 into 3 is 6. 2 plus 6 is 8 by 3. Let's just see. 2 plus 2 into this is 2 into 3. Root 3 into root 3 is just 3. And divide by root 3. 2 plus 6 upon root 3, which is 8 by root 3. Hence, it is satisfying this condition. Okay. Now, let's just check for the product part. This was the sum part. Now, we will check for the product part. Suppose product is what here? Product says that alpha dot beta. What is the value of alpha here? It's 2 root 3 into what is the value of beta here? 2 root 3. That should be equals to c upon a. What is the value of c? 4 root 3 upon a is just root 3. See, root 3 upon root 3 will get cancelled out. 2 into 2 is 4, and here also root 3 will get cancelled out. What will remain here is just 4. So LHS is equals to RHS. So the product part is also satisfied for this. So hence our zeros of this quadratic polynomial, that is alpha is equals to 2 by root 3 and the beta is equals to 2 root 3 is true and fully satisfied for this equation root 3x square minus 8x plus 4 root 3. Let us take another example. Dear student, there was a glitch in the audio, so I am recording it. I am giving the voiceover. So here we are going to deal with the third polynomial, that is p of x is equals to 5x square minus 34x plus 24. So we will solve this question also as how we have solved the previous two questions. So let's go for it. Solution. Here, on comparing with the standard formula of the quadratic equation, that is ax square plus bx plus c, we get the value of a is equals to 5, the value of b is equals to minus 34, and the value of c is equals to 24. Here, again, we have to think about two numbers p and q such that their sum is middle term, that is minus 34, and their product is the multiple of constant and the coefficient of x square. So let's go think of two number, say P and Q, such that their sum is midterm, that is B, and their product P into Q is constant into the coefficient of x square, that is C dot A. Here you can see the value of B is minus 34 and the value of C is 24 and the value of A is 5, and we know that 24 into 5 is 120. So we write 120. Okay. Now by hit and trial method, try to think about the value of P and Q. Here I can write this 120 as the product of minus 30 and minus 4. Okay, so the product of two negative number is always positive. So when we multiply minus 30 and minus 4, we get 120 as a value. And also on the other hand, we can write minus 34 is equal to minus 30 minus 4. Okay, so the value of P and Q is anyway, it's minus 30 and minus 4. So let's just put the value of P is equal to minus 30 and the value of Q is equal to minus 4. Now we will split up the midterm of the given polynomial P of x, 5x square minus 34x plus 24. So this midterm minus 34x will be splitted as a 5x square minus 30x minus 4x plus 24. Now this implies that by taking common from the first two term, we can take 5x as a common. So taking 5x as a common, the remaining thing will be x minus 6. And from the other two remaining term, we can take 4 as a common. So the common will be x minus 6. So here P of x can be written as 5x minus 4 open bracket close x minus 6 open bracket close. This is called factor of the polynomial. Now again, in order to find the zeros of the polynomial, we will put the factor of this polynomial equals to 0. So putting 5x minus 4 is equal to 0. On the other hand, we will have x minus 6 is equal to 0. So transposing 4 to that side, that will be 5x is equal to 4, and the value of x, again by transposing 5 to there, it will be 4 by 5. On the other hand, when you transpose minus 6 to that side, the value of x will be 6. So x is equal to 4 by 5 is the value of alpha, and x is equal to 6 is the value of beta. Now we want to check whether the value of alpha and beta that we have solved is true or not. To check, we will use this relationship between the coefficient of quadratic polynomial and their zeros condition. The first condition is alpha plus beta, the sum of the roots should be equal to minus b by a. So putting the value of alpha, that is 4 by 5, and the value of beta, that is 6, that should be equal to minus b. Acha, now see. Minus b, so the value of b is minus 34, so minus minus will be positive, so that will be 34 divided by 5. Okay. On the LHS side, we can solve it as by taking LCM, that 4 plus 6 into 5 divided by 5. That should be equal to 34 by 5, and 4 plus 6 into 5 is 30, so 4 plus 30 is 34 divided by 5. 34 divided by 5. This shows that 34 divided by 5 is equal to 34 divided by 5, which shows that LHS is equal to RHS, which here proves that it satisfied the first condition, that the alpha plus beta is equal to minus b by a. Now we aim to verify the second condition for the same, that is alpha dot beta, that should be equal to c by a. Here the value of alpha is 4 by 5 and the value of beta is 6. That should be equals to c. The value of c is 24 and the value of a is 5. And we know that 4 into 6 is 24 24 divided by 5, and that is 24 divided by 5. Here also LHS is equal to RHS. This shows that this, again we have satisfied the second condition for the verification. First and second, both conditions are satisfied. That shows that the value of alpha that we have obtained is true for this given polynomial. Dear student, in this video lecture, we have learned about what is the zeros of the polynomial, how to plot linear and quadratic polynomial, finding the zeros by using splitting the midterm method, and to verify the zeros, we have used relationship between the coefficient of quadratic polynomial and their zeros. So keep practicing more questions. Thank you everyone.